Not all radical expressions will simplify without a radical in the denominator. When a radical expression appears in a denominator, it can be useful to find an equivalent expression in which the denominator no longer contains a radical. This process is called rationalizing the denominator. If the denominator is a radical expression, we must write the radical expression in simplified form by rationalizing the denominator. Have you realized that this is important? Yes. That is, we rewrite the expression to make the denominator a rational number and eliminate the radical. So basically, to rationalize a denominator, you get rid of the radical in the denominator. To rationalize a numerator, you get rid of the radical in the numerator. And there's a way to do this quite simply. You just have to figure out what you're missing to get there. So let's look at these examples. This first fraction already has 2 over root 5. So this is simplified as far as it can go, but we do need to rationalize each denominator. So what we're looking for is the number we can multiply to root 5 that will undo the radical. Since the index on this denominator is 2, we're looking for a fraction equivalent to 1 that when multiplied to the root 5 will undo or get rid of the radical. In this case, root 5 multiplied to root 5. Remember, they're square roots. That would give you the square root of 25, which would come out as just a 5. And so we can rewrite this as 2 root 5 over 5. Let's try that again. In this second example, B, we have 2 root 5 over 7 root 3. The 7 doesn't need to be worried about. It doesn't have a radical in it. But the root 3 needs to be multiplied by something so that when it's multiplied to that something, the radical drops out. So root 3 over root 3 will give us that thing we need. 2 root 15 over 7 times 3. Now, this is kind of sloppy. We're not quite there, but we got rid of the radical. So now it's just a process of rewriting it. 2 root 15 over 21. Let's try C. C is 2 over cube root of 5. Now, in this case, we can't use cube root of 5 anymore. We have to multiply by something that will build up the radicand, the part inside the radical, by something to turn it into a perfect cube, not a perfect square. So we need the cube root of 25. Because now 5 times 25 will give us 125, and 125 is equal to 5 cubed. So it is now a perfect cube. Whatever we multiply in the denominator, we also have to multiply in the numerator. And since we have a perfect cube now, the radical, the cube root part, will go away, and we'll be left with 2 cube root of 25 all over 5. And that does not reduce. Let's look at part D. We have the cube root of 3a over the cube root of 5c. We need to build up the denominator to turn it into a perfect cube. So we'll have to use the cube root of 25c squared. Same thing in the numerator because it has to be equal to 1. This gives me the cube root of 75ac squared all over 5c. Lastly, we have the square root of 10ab squared over 72a cubed b. Let's simplify this first. We have 10 over 72. This would reduce to 5 over 36. A over a to the third would give me an a squared in the denominator. And b squared over b will give me a b in the numerator. Now 36 is already a perfect square, and so is a squared. So now we have the square root of 5b over 6a. And that one we didn't have to rationalize because it's simplified and got rid of the radical on its own.